Good evening, everyone. Here's your favorite math tutor. Yeah, self-proclaimed. Hopefully everyone is doing well tonight. I know it's a Saturday evening. It's 8:30. It's not our usual date, but it is our usual time. So, hello, everyone. Hello. Present. Yes. Way to go, Native Ash. Welcome, everyone. Yes. So, I know you're probably like, is this woman ever going to take a day off? Yeah, maybe. But I just came across something that I was like, you know what? I want to show something. I had a couple of phone calls and I was like, you know what? Why don't I just sit my butt down, put something together, and get you guys situated? All right. So, I want to say yesterday, either yesterday or the day before yesterday, someone was asking me on one of my lives of how to break down piecewise functions. So I'm actually going to do a little bit of this and then show you and basically tell you what is the cool thing that I put together that can be really beneficial for especially those people that are taking the GED or they're taking the ASVAB or the ACCUPLACER. Or maybe you just want to do a little bit of more work on just trying to get your algebra skills back up. Maybe something that'll kind of help your kids out. So I know some people are doing what's called piecewise functions. So if we take a look, let me zoom in a lot. So piecewise function is basically an expression. Then they give you an if statement, and then they give you some kind of inequality. The best and easiest way that I can explain piecewise function is like this side is going to be the keys, and this side's going to be the doors. And I don't mean Jim Morrison. I know I just aged myself really quick, but but you know, we have some of the doors. So the way that you read piecewise function is not how we read here in the States, from left to right, okay? Most people read from left to right. When you do piecewise functions, you have to read from right to left. So you're trying to see which of your keys is going to fit in the appropriate door so it can open up. So here I have x is less than -2. And then here I have x is greater than or equal to -2. So if I gave you a number, let's just say I gave you a number that was, let's say -1. Let's say I'm looking at the f of -1. So I want to know which one, and if you remember, f of -1 is the standard from the f of x. So the x is always what's inside of the parenthesis. So I want to know which one of these two should I use to find what my y value is. All right. So hello, Sassy. Thank you so much for coming back actually. So now I have -1. Which of these is going to be a true statement? With the inequality, this is less than. So I'm saying, is -1 less than -2? Or is -1 greater than or equal to -2? All right. Hey, Manny. So thanks for the follow. If you recall the number line, let me just kind of show this. And let's just look at the x-axis. So I'm looking at -1, which is right here, in comparison to -2. So is -1 less than or is it greater than -2? Okay, what do you guys think? Upload it on your YouTube? Yes, it will be. Yes, it will be. It will be uploaded on the YouTube. Okay. So what do you think? Is -1 greater than or less than -2? So I got a couple people. Got I that says greater than. Matt. Oh, Matt is greater. Mila. A greater. Negative. Less than. Hello. Is this for limits? It's not just for limits. I'm just doing piecewise functions. So I'm not going to the extent of that, Ashley. But it is greater than. Good. All right. So since it's greater than, that means which of these two am I going to use? Is it going to be the first one or is it going to be the second one? So since -1 is greater than -2, which one am I looking at? The first one, which is x is less than -2, or am I looking at the second one, which is x is greater than or equal to -2? Good. I have the second, yes. I have the second, yes. The second, yes. Okay. So we're looking at the second one. So that means this is the key to open this door. So that means when I plug in my f of -1, my y value is just going to be -4. And the reason why it's just -4, because that's all I have as the expression, right? So this is telling me that any number that is greater than or equal to -2, my answer is always going to be a -4. Okay, so even if I wanted to say the f of 5, all right, obviously 5 is not less than -2, it's greater than -2, so that means I will come over here, my y value is going to be a -4. All right, so the x values is going to see which one is going to give me a true statement. Now, if I said f of -2, which one's going to be? The first one or the second one? Hello, Data Tech Mom. Okay, so if I said f of -2, which one am I looking at? The first inequality or the second inequality? Hello, Holly. Okay, your cute jeans 77 says second. Data Tech Mom says second. Can I get 2 more? Okay, Cora. Well, hello, Cora. Says second. And Triumph Track says second. Good. The reason why it's going to be the second, not the first, is because of that line that's underneath the inequality sign. So this means greater than or equal to. So since -2 is going to be equal to -2, that means we're using this second inequality. So my y value, again, is going to be -4. All right. So what happens if I said f of 0? Okay. What happens if I say f of 0? Which of the inequalities am I looking at? The first or the second? F of 0. Okay, Cora's saying the first. Amber, hello, Amber, says the first. Your cute jeans, take a look, 0. We're comparing it to -2. The second, Vino, 0. Stargazer, second. Jessina. Did I say that pronounced correctly? Okay. So 0. 0 is bigger than -2. Okay. Can 0 be a function of g of x or of x? It can be. Okay. Because it all depends on the situation. So since 0 is larger than -2, it is going to be that second line. All right. Yes. All right. So now if I said f of, let's stop playing around. So f of -5. Okay. First or second. F of -5. Let me see if I unzoom just a hair. F of -5. What do we got? The first or the second? Okay, we got second, we got first. Hey, Taz, second. Rob, hello, Rob, first. Okay. Can I get one more person? And if you're not sure, I also accept question marks. Okay? Because we're here to kind of learn and do a little bit of processing. So do not freak out. All right. Okay, we got first. All right, thank you. So -5, if I come back to, I'm just going to use just the x-axis for a second. So here's -5, here's -2. So -5 is less than -2. So since we're using less than, which key is going to open which door? It's going to be your first one because -5 is less than -2. So this is the key. That means I need to plug my -5 in this expression. So that means we have -5 plus 5. That means the f of -5 is going to equal 0. Okay, so we found the order pair of -5, 0 to take over for that first expression. All right, good. Good, Jay. Lovely to see you. Hello. Is that Lady Marie? Egg Marie? All right. So, with that being said, okay, if you were to graph this, here is my suggestion. I would do pencils until you get used to the whole process. All right, this is just me. So since we have two inequalities, this is going to give us a line. This is also going to give us a line. All right, so these are two lines, but we don't want the whole entire line. That's why they call it a piecewise function, because you're only graphing part of the line. Now, if we go back many moons ago, when we used to graph inequalities, so let's say I have a graph of inequality, here's a -2. When it's just less than or greater than, remember there was an open circle. And then we did some shading. So we said, okay, x is less than -2. That means I would do my shading over to my left. So that means any number that was less than -2. So we could say -3.5. We could say -10, -500, 602, or 500, 602, 562. There we go. Or anything all the way to -infinity will make that into a true statement. All right. Thank you. Perfect. Okay. So now, if I were to graph the second inequality, just on one number line, okay, I'm going to put here's -2. Since it is greater than or equal to, if it's equal to, we're putting a dot. Okay. And since they're saying greater than and equal to, that means I'm looking at numbers that's equal to -2 all the way to positive infinity. Okay, so for the bottom one, when you have the line underneath the inequality sign, you're including that number. But when there isn't a line underneath the inequality sign, you're not including that number. You can get as close as you can to it, but it will never equal it. Okay, wait, what was the question? I'm not even sure if I asked the question. That is kind of true. I think I'm just about to get into piecewise function and graphing. So what I'm trying to do is I'm just kind of like do a quick review of when you used to graph it on a number line, when it was just one number, because this part with the open circle and the closed dot, that's kind of important, especially when you're about to graph the piecewise function. Okay, yes, good, Taz. Yes, because we can go as close to it as negative 1.999999999. I feel like Chevy Chase when he was on Caddyshack. Anyway, showing my age again. Paco! Hola! All right, so what we're going to do, and as I said, sometimes it's easier to graph with the pencil because we might be doing some erasing. You're not graphing the whole entire line. Now, the restriction that we need to know is at -2. So I like to say, if I show my graph, let me band it up a little bit. I always like to put a boundary line right at the -2. If that's hard to see, let me use a pen. Okay. All right, so that's my boundary line. That's when x equals -2. So it's either you're going to draw the line that's going to be to the left, or you're going to draw the line that's going to be to the right. So I kind of like to have a boundary line to kind of figure out where I'm going to be. So if I were to graph this first equation, which is x plus 5, right? So if I'm trying to graph that first equation, it's usually y equals x plus 5. Traditionally, what would be my starting point? Where would I start? Yes. So to go back, any number to the left is less than. It's less than going to -infinity. To the right, anything greater than, and it goes to positive infinity. Hello, misbehaving. How are you? Yep, less to the x. All right. So where do we start when we're graphing y equals x plus 5? Where do we start if we were normally going to graph the equation of the line? Okay, not at the 1 and not at the x. Okay, usually you would start your pencil at the 0, but if I were to graph, where for the y equals x plus 5? Okay, so I'm saying the origin, Nick, we got the y-intercept. Good, Tawny is at 5, Jennifer is at 5, Jay is at 5. Beautifully defined is at 0.5. Hello. It's good to see you again. All right. So you always start at the y-intercept. Okay. You always want to start when they give you the equation of the line. Your starting point is always going to be your constant. Okay. Your y-intercept. So that means on the y-axis, my first point would be here at 0.5. All right. Now, from this point, how would I draw my next point? Are we looking for the answer to the system of equation? Not to the system. We're going to do piecewise, but I'm going to show everybody like step by step what's happening. Yes, we are going to do rise or run. So Simply Angel says up 1 over 1. Holly says up 1 over 1. Good. Because what's in front of my x? What's assumed to be in front of my x is a 1. So anytime it's a whole number, you put it over 1. So if I go up 1 and over 1, I draw a point. If I go up 1 and over 1, I draw a point. Right? Okay, good. Good smiling. I'm going to see if I can turn this off. See what this will do. Okay, not too much of a glare. All right. Okay, so it's not that overhead glare that I have. Now, normally we will draw the whole entire line, but we're doing piecewise. So we're not drawing the whole line, we're drawing part. The part of the line that we're drawing is when x is less than -2. So we're not graphing the right side, we're going to graph the left side. So if my slope was going up 1 over to the right 1, that means we can go in reverse. We can go down 1 to the left 1, down 1 to the left 1, until I get to my boundary line. But remember, it says, let me see if I can zoom in. Oops. Remember, it says x is less than -2. And when it's less than, we're going to use an open circle. So where my pencil is, I'm going to put an open circle. Try to get that shade. But then I continue going down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, until I can see my line. Ooh, where's my other pencil? There it is. So you're not graphing the whole entire line. No, you're graphing from -2 all the way to -infinity. So these points that are right here on this side, we can erase. So it's going to be an open circle here at -2, but then we're graphing the points so we can go down the other side. Okay. All right, so let me see how we're doing, because I know, okay, I'm confused as ever. Okay, same, good. I don't remember learning this in high school. Hey, okay. So down 1 to the left 1. Yes, Jay Nicole. Thank you for the follow. I'm confused why you're putting 1 over 1 next to the 6 and 6 and 5. Why not down next to the 1? Trying to see what we're talking about. I'm confused why you put the up 1 over 1 next to the 6 and 6, 5. Why not down next to the 1? Let me see if I understand correctly. So the y-intercept originally was -5. It was a +5, which was right here. And my slope had me going up 1 to the right 1, which should be at 1, 6. Okay. And then you're saying 6, 5. Because we started at the y-intercept, which is 5. Okay. Tawny, are you seeing it? Because I'm like, 6, 5. Why not next to the 1? Oh, okay. Yes, that's what Tawny's saying. Thank you. Okay, Holly. So my y-intercept is going to be the 5. So we started here at the 5. My slope is telling me the direction where I need to go to draw the next point, which was up 1 and over 1. But since we're doing piecewise function, that means we're only graphing what the limit or the restraint is. And the restraint is telling me we want to only graph when x is less than -2. So by me drawing the boundary line at -2, if I follow my line, if I continued on, I would go down 1 to the left 1, following my slope to see where would it be on that boundary line. And it's going to be at -2, +3. Then you keep going with the flow. Down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, and you can just draw your line. So that means if I went with -3, I got -3, +2. If I went with -4, it should give me a +1. So I'm finding the y values graphically. Okay. Is it because 1x is added to 5? Okay, Gretchen, I would forever be jealous of people who are smart, who are good at math. Serena, you're going to be good at math. Relax. It's going to be okay. Okay. So is it because 1x is added to 5? I'm trying to understand. And beautifully defined, yes, you got that part. What do you mean by, is it because 1x is added to 5? Okay. As far the reason for going over, yes, because we're going up 1. So the reason why we're going the opposite is because we want to know what that graph looks like on the opposite of our boundary line. So we need to figure out what point. I mean, I can easily just plug in. If I wanted to, I could plug in the -2 for the x. If I plugged in -2 plus 5, what's -2 plus 5? Because this might be a little bit easier. So -2 plus 5 is 3, right? Is 3. Good. Notice where we put the circle. The open circle. When x is -2, my y value was 3. Okay? So if us drawing the whole entire line is confusing, we can do that as a boundary. Would that make it simpler? Talk to me. Because I can do this multiple ways. Does it make it easier when I know what the restriction is and then plug that restriction into our expression to see what we get out for a y value? I have a glitch. Okay. Okay, show a different way. Okay. So it's either we graph the whole entire line from top to bottom and then erase the right side of the line. Or we take the number, which is the boundary, which is -2, and plug it in to our expression to get the +3. And that's where we're going to put the circle. Okay. Okay. All right. So that's one side of the line. Now we got another equation. The boundary again is that x is greater than or equal to -2. So since it says or equal to, remember it's going to be a dot this time. But we don't want to graph the whole entire line because now it's just at -4. -4, that's going to be a horizontal line through -4. Okay? Anytime they just give you a number, that means that's what you're going through on the y-axis. But The boundary line is right here at -2. And we want to graph not the whole thing, but just to the right of it. Okay. So that -2 is like your boundary line. That's why I kind of like putting the boundary line. And then I look at my inequalities. If it's less than, that means I'm working the left side of the graph. If it's greater than, that means I'm working the right side of the graph. How we're doing. It's just a constant. Yes. Okay. Meaning in another problem, if I had 2x, you would go up 2 and over 2. If you had 2x, you would go up 2 and over 1. Anytime your x value, let me put it up here for a second. So if I said y equals 2x minus, 3. So anytime your slope is a whole number, you put it over 1. So my rise will be 2. And my run will be 1. Okay, does that make sense? Hey! Hey, friend! Yep, just doing a little bit of piecewise function, and then I do have an announcement. Okay, perfect. Okay, that's perfect sense. Awesome. Yay! You're so welcome. All right. Because I can't remember who asked me to do this, but I'm really glad that they did, because now here we are on a Saturday night. Look at us. All right. So now this is how you graph a piecewise function. All right. So you have your boundary line, and your boundary line comes from the inequality side. Then you could use the number that we have, plug it into the expression, so we know where we're going to put our point, our starting point. But remember, if it's just less than or just greater than, it's an open circle. If it's greater than or equal to or less than or equal to, it's a solid dot. All right. Good. Okay. All right. Thank you. Look, I'm a mom, and I'll pulling my hair out trying to help my daughter. And that's the thing. That's one of the reasons why. And I talked to another colleague today, and I said that if I can get parents to feel empowered to help their kids, because I know it's like almost like sabotaging my whole tutoring business, but I'm here. Why not? But if I can empower parents to be like, you know what? I think I can help you with that. Like, how awesome would that be, right? You just sparked my curiosity. I really want to learn how to solve math problems. Awesome. Hey, that's great. It's like I remember learning about rise over run and which sign is an open or a closed circle. Good. I'm grateful. Good. Awesome. Don't worry about spelling with me. That's why I'm a math teacher, not an English teacher. That's why I always tell people when they say, oh, can you help me with the SATs? I'm like, yeah, just the math part, because English you will surely fail. So, hey, V. All right. Lovely to see you. Okay. Let's try one more time, and then I'm going to make my announcement, but then I'm coming back to this, okay? I'm coming back to this. All right. So, let me zoom in a little bit. So here we are. We have our f of x, and we have two expressions this time. So we have our x is less than 1, and our x is greater than or equal to 1. So I always remember, you got to read it not from left to right, but from right to left. Think of it this way. I have a whole bunch of keys, and I want to know which key is going to open the door. All right, so taking a look, it looks like my boundary line is going to be at 1 because this one's saying x is less than 1 and x is greater than or equal to 1. So my boundary line on my graph, I'll just use it in pen, I think it's easier to see it, is going to be at 1. Okay, so I'm drawing a boundary line so you know when x is equal to 1. Are we okay so far? Okay. All right, some people are joining in. Yes, I would highlight 1. You want to highlight it too? Sure. Yeah, when I was in the classroom, I used to use highlighters all the time. Okay, got it. Not a problem. Yes, okay. Got a couple yeses, got some hearts. Thank you. And if you could take a moment to give a little bit of love, I would greatly appreciate it. If you know of anyone that can benefit, and I know they're going to be like, girl, it's Saturday night. I'm like, girl, you want to pass that test? Tell them, share the live to them. You know, especially the GED, if they're thinking about ACCUPLACER, if they're thinking about ASVAB, sometimes they like to slip in one of these problems in there. And remember, if this is in the GED, the Piecewise, this is clearly a 4-point question. Okay, remember, all the questions are not evenly graded. So go ahead and just pass it on to someone. Aw, you know people. Yeah. It's like, I feel like a need. You feel like a need or you feel like a nerd? It's okay. Either way, it sounds cool. All right. It's like a sharp line follow. And yes, we're going for GED for her. All right. Awesome. Okay. So now we have our boundary lines. So if we take a look, I want to know where I should put my circle or dot on that boundary line. I think this will make it so much easier. Okay, so if I come over, just gonna tweak that a bit. If I come over, I'm gonna plug in my 1. So this is for the first one. I'm gonna plug in the 1 for the x. So I'm doing the f of 1. Okay, and this is for when x is less than 1. Okay, so I'm going to plug in what my boundary line would be in for the x in the expression. When I do that, what do I get as a result? What would I get as a result? Okay, look at this. Look, 3. I'm guessing. And guess what? You guessed correctly. So proud. So proud. I just have to build up those confidence. I'm so proud that you did not put a question mark at the end of the 3. So good job, LA. J. Nicole, yes, 3. 2020 Rainbow Twins, 3. Yes. Southern Life, you multiply the 2 and get 1, and next you add the 1 and you get 3. Yes, Southern Light, good job. Life, good job. Hey, Martin, yes, 3. Zara, 3, good. All right, so we go to the graph. When my x is 1, my y value is going to be 3. Now, look at the inequality. Is it going to be open or closed? That's vital. Our natural habitat is to just go ahead and put a point there, but we have to take a moment to see, is it going to be open or closed? So we got a controversy right here. We got V says open and Tears Blonde says close. It says close. Let me zoom in. Oops. Okay, So I'm looking at the first one where it says x is greater than 1. All right, saying open, open, left hand less than, so it's equality. It is not included. I'm seeing open, I'm seeing closed. Okay, so I'm seeing a mixture. So let's go back to it. If I were to graph this on a number line, I got my 1. We're saying x is less than 1. That means it's not including 1. So it's going to be an open circle. Less than, I normally would shade all the way to the left, all the way to negative infinity. Okay? So when there isn't a line underneath, it's open. It's not going to include it. Okay? Good. There we go. But if there is a line underneath, that's going to be closed because you're including the 1. All right. To positive infinity. Okay. So for this one at 3, we should, here's 1, 2, 3. I think I'm on the graph is in here. Now you can see the graph. Okay. So up 1, 3, since it's not a line underneath, it's not including, so it's going to be an open circle at the point 1, 3. And the reason why we're saying 1, 3, the x value was 1, and the y value that we saw is 3. Okay. I mixed it up. Sorry. Not a problem. Please. We're just here to learn. Trust me. I keep saying it on here. This is definitely, it's not a life or death, it's not a life or death situation. Okay? So, it's not Squid Games. All right? It's not like you get it wrong and then you're done. All right? We're just going to learn from the process. Now, taking a look at this expression, it was 2x plus 1. If I think of it like a line, if I think of it like a line, 2x plus 1, what's my slope? Is it the 2 or the 1? Okay, if it's not greater than or equal to or less than or equal to, it's just less than or greater than. Yes. It's going to be an open circle. Yes, Southern Life. Good. We got the 2, we got the 2, we got the 2, we got the 2, 2 over 1, 2 over 1. Okay, we got the 1s, we got the 1s. Up 2 over 1. Yes. All right. So our slope, remember, the slope is always right next to the x. Remember, mx plus b, the m is your slope. Your slope is always the coefficient to x. So from our point that we have on our graph, that open circle, let me use pencil. So that means we're going to go from this point up to 1, 2, and since it's a whole number, over 1. Draw a point. Okay, we're going to go up to 1, 2 over 1. Up to 1, 2 over 1. So now you can see that line that's being drawn. Okay, and then we just, boom, right to that point, draw our line. Draw our, not our line, draw our ray. Woo, look at us putting some geometry into it. Okay, so, all right, good. Because once we figure out where our starting point is on the boundary line, our y-intercepts are not going to help us because we're not graphing the entire line. If they told us to graph the equation of the line, yes, you start at the y-intercept, okay? But we're only doing piece or part of the line. So why not start, which is going to be near that boundary line, and then you take your slope, which is the 2, And then you go up 2 over 1, up 2 over 1. You can repeat it as many times as you can till you see the rest of the line or the ray. Okay. Okay. So it's not going to be down 2 over 1. The less than symbol is telling us which way of or which side of the boundary line that's highlighted that we're going to represent on the graph. That's what the inequalities are for. Which, I think you're right. That's why I did it in pencil. All right. So, and you are right, because if I'm going to go, we only want when x is less than 1. This is when x is greater than 1. So that means instead of going up 2 over 1, we're going to go down 2 to the right 1. Look at that. Down 2 to the right 1. Say, Audrey, did you do that on purpose? No. Do you want me to lie? Sure, I can lie to you, but what's the freaking point of that? 1, 2 to the right 1. Okay? Down 2 to the left 1. I keep saying right. 1, 2 to the left 1. I'm drawing left, but I'm saying right. So, yeah, what's wrong with me? All right? So this is why I do piecewise in pencil. If you see any of my other videos, you've come in here before, you're like, oh, Audrey, you're always doing it in pen. Yeah, because I don't want this side. I just want the left side. Okay, wait, let me give credit and credit's due. Who said that first? Was that Simply Angel? Hold on. Yes, it was Simply Angel. Thank you, Simply Angel. Thank you, Simply Angel. Okay, the reason why, because I saw the what, the reason why we are only to graph the left side. We only need to graph when x is less than 1. So this is where 1 is. We need to graph the side that's less than 1. So we have to graph the opposite side. So it's almost like when they said up 2 over 1 and we found that line. If you want to draw the whole entire line and then just erase the right side, you can do that. Okay? Or you can think the opposite of the slope, which would be a -2 over a -1. So I would go down 2 over 1, down 2 over 1. So I can get, notice I still have a positive slope, but the way I'm counting is in reverse because we're only treating the left side. Oops, the left side of the graph. Okay. All right. Okay. So now we're not done. We still have the other equation to do. So the other equation or expression deals with -2x plus 3. But we're dealing when x is greater than 1. So how to find that point? We're simply going to take our f of 1 and we're going to plug it into -2, plug the 1 in for the x, plus 3. So we want to find that point that's on this boundary line. All right. Okay, let's see. Lesser than 2 is like we say -2, right? Yes. Okay, so we got 1, because -2 plus 3 gives me a +1. Good. Okay. So the order pair that we're looking for when x is 1, our y value is also 1. Now, are we going to put an open or closed? So we're looking at our inequality. Is it going to be an open or a closed? Okay, Jay says closed. Okay, closed. Good. What else? Okay, and if you're not sure, put a question mark. Remember, that's an option too. Okay, Stargazer, closed. Okay. So you answered it, but then you put a question mark. Why? Why? Why did you put a question mark? You answered it, and then you put a question mark. Probably saying, because I'm not sure. And I'm like, close. It includes Holly. Okay. One more. Good. Michael R. closed. I was like, I'm not 100% sure. Okay. It's closed because the 1 is included because it's greater than or equal to. Thank you, Jay. Okay, so you guys were right. All right, since there is a line underneath the inequality symbol, that means you're including that point. You're including that point. So here, let me slide over at 1, 1. So here's 1, here's 1. It's going to be a closed dot. I'm confident with that with pen. I'm fine with that. And since they want us to do x is greater than or equal to 1, that means I need to graph the right side of this grid. So now I need to look at my slope. My slope says -2. So that means from this point, I'm going to go down to 1, 2 over 1, down to 1, 2 over 1, down to 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And then from there, then we have our graph. Okay, so open circle at 1, 3, then a closed circle at 1, 1. The second equation deals with everything to the right of the boundary line. The first equation dealt with everything to the left of the boundary line. Okay, piecewise, yes, Morgan, hi, it's good to see you again. I thought we had to go up to since it's greater than 1. No, the x values are going to be greater. The x values are greater than 1. But your slope, you're going to follow the direction since we're doing the right side of that graph. Okay. Okay. Hello. Oh, thanks for the follow. Hey, Deb. All right. So I am going to do more. But I just want to take a quick pause. So while you're here, if you can tap, I'll greatly appreciate that. If you can share, this will be the perfect time to share. Also, if you have a small business, okay? Tonight, what happened tonight? Yes. So if you have a small business and you want to share your small business, go ahead. This is the perfect opportunity to do that. I'm a type of person that I like to share platforms because trust me, I know how it is when you're first starting and you want to tell everybody what you're doing and people are like, no, this is not the platform like they usually do. Okay, show the equations, please. Sure, let me unzoom so you can see I think you'll be able to see everything. Is that okay, Marvin? Can you see everything, Marvin? Can you give me a thumbs up? Okay, cool. All right, so for those that have been coming to me here and there, this is not my usual paper. Usually I'm writing inside of my math notebook, but I have officially launched my online courses. So I have courses that is for the GED. I have courses for ASVAB. I have courses for the ACCUPLACER, and also one for if you just need foundational skills. Now, you're welcome. Now, because I was trying to do for the longest time to fit up with some people, and I had some meetings, and I've been trying to organize my times because I still have clients, as well as to help support people individually. And for some reason, our times just can't match up. So this is what I decided to do. Since I have these courses, now you can basically have me in your home. Be gentle with me. Doing these coursework. And what I was planning on doing is when I give you the course, you can go through the course, but whatever stumps you, you can basically send me like a picture of whatever the problem is, send it to me before my live shows. So you know how I go live on here at 1 o'clock Monday through Fridays, and also 8:30s on Mondays and Thursdays. I would take those questions first and then go into our regular scheduled program. So it's like you got me to help you, but instead of having individual one-to-one days, it'll be better for me to give you the course and you can go by the course yourself, but then get the support during the lives. And if for some reason you can't make it those lives, guess what? The lives are being recorded. So I can always say, all right, here is this person's questions. I'm going to send you the recording of that or post it on my YouTube channel and just, put, timestamps on it so you can get to it so much quicker. Because I don't want you to say, okay, let's sign up for a one-to-one. We see each other once a week. That's going to take a lot of time. And then plus you're going to have to wait a week before you can get to the next thing. Yeah, that's just too much. And since you really want to get this done quickly, it just seemed like it made sense for me to say, all right, let me present a course for you guys. It's 107 different videos, instructional videos. I walk everything through just like how I do in my lives, step by step. That's all I know how to do it, right? Then I have practice tests, practice papers with answer keys. And then again, you can get me to help support you. Okay. How does that sound? Like, go ahead, put it in the chat like, yes, this is amazing. Or you're wasting your time, girl. Like, what's happening? What time zone do you go live? Eastern. Yes. So 1 p.m. Monday through Friday, Eastern Standard Time, and 8:30 on Mondays and Thursdays. Okay. Can you use Desmo's graph app for piecewise equations? You can. You can. I'm not sure how to. And then plus with my apparatus, you should see my setup. It's hilarious. Like if I sneeze, like everything is going to go down. Probably the internet as well. All right. Oh, thank you. It's like, this is awesome. Good. All right. I was trying to figure out to approach tutoring so you can answer my prayers. Yes, because I figured it'll be easier for me to just do a course, get it set up. Now, here's my thing. Because I would love to continue to do stuff for free, but here's the thing. Life is not like that, okay? I'm going to be truthful. I'm going to get real with it. I'm trying to understand how they work and when to apply each other. Thank you. Try to understand how they work? What do you mean how they work, Holly? I'm trying to understand. I'm getting into the middle of a conversation. Okay, I could more than likely use the service, but I'm in school through distance learning. Okay, that's not a problem. Yeah, because I know, especially for those that are doing, especially GED and all that, but if you still want one-to-one tutoring, that is an option as well. Okay, so I'm thinking of, and this is what I have on my website, until March the 1st, okay, till March the 1st, we're going to use it as a subscription. Now, hear me out. So I know I usually tutor for my one-to-ones. My cost of my tutoring is $87 per session. Yes, is $87 because I'm good at what I do. And then plus I always do extra stuff. You know, that's how I am. But instead of doing that for the course, I wanted to make it into like a subscription, like a monthly subscription. So I was going to make this price. Let me just write everything down so you guys can see it because it'll be a lot easier. So I'm looking at a 3-month subscription. Total cost per month will be $57, okay, per month. And that you will get 107 instructional videos. I'm just going to have in videos. And when I do instructional videos, my videos are not like 3 minutes long. Like you see how I do things step by step and process by process? Like this is what I'm doing. So yes, that's how much I charge. Okay, that's the same person. I already did that part. So now you get the instructional videos, you get practice problems with answer keys, okay? And you can, anything that you have a problem with, you can contact me, okay? You can contact me to break information down, just like I do now. So this week I have done, I think I did like 4 sessions with people from TikTok that came up to me. And this is all I'm looking at. So say that you're taking the GED. So here's something else a lot of other people do not do. So say you're taking the GED like next month, right? And you pass it. Guess what? That 3rd month, you're not paying. I'm going to forego that. Some people will say, if you have to give me like a 3 months. If you want to keep going and keep paying per month, you can do that. That's perfectly fine for how many months that you need, how many months that we need to break down concepts. My suggestion, if I may, if you haven't taken the GED and you're trying to take it, go and take it one time. No expectations. Just see what you can do so you have like a baseline. Okay? And I think most places have the GEDs for like either, I know here in Maryland we have it for like $10, but there are some places that you can get it to take it for free. But if you are going to take the test, just go and take it so you got a baseline. And then let's go with everything in process and all that stuff. Hey, Janae. All right. So that's really what I'm looking at. You know, I really want to support you guys, but at the same time, if we try to do individual one-to-one sessions, there's going to be too much of a breather. Hold on, I got to do this puzzle thingy. There we go. There's going to be too much of a lag, and I don't want that to happen to you. I don't want you to have to wait another week and then it just prolongs everything. So yes, I can plan to take mine in the end of March. Okay. It's like I failed GET 5 times. Hey, Chris, it doesn't matter. The math is hard, especially if it's math that you're not used to seeing. And here's the other thing, Chris. If you can get anything that was with the linear anything to y equals mx plus b, a lot of the stuff that I've been teaching like last week and possibly the rest of this week, the graphing of it, system of equations, those are 4-point questions. If you can get 2 or 3 of those bad boys and do well with the regular arithmetic, with the fractions and the decimals, you'll be able to pass it. Hands down. You have to get that algebra part. You have to get that linear piece in order to pass it. That's the only way. Because there was a lot of people that had slope-intercept form, graphing, how to read the graph, and how to graph a system of equation and solving a system of equation. Like those were like the main ones. I want to say like 3 years ago. And I don't know why the algebra. Yep, definitely. So like if you can get those down and then have a good understanding with the basic arithmetic, you'll be able to pass it. Seriously. Okay. I timed out the last time I took it. Yes. And usually based on the test, because it is a timed assessment, you have about 2 minutes and 50 seconds. No, sorry, I lied. 2 minutes and 15 seconds per question. And you got to understand, there's going to be some questions that the answer is boom. As soon as you look at it, you got it, move on. And then you're going to take that extra time and apply it to those questions that you didn't quite understand. Okay? All right. All right, well, because I can't even speak. The score is like what? 145, right? I'm so excited now. Good. So everything happened in my life aligned when I came across your live. Oh, thanks. Yeah. So look how close you are. Now, if we can just tweak possibly a couple of those equation the line problems, you'll pass it. That's what it is. When is a good book to study GED? Well, I've done some work through Kaplan. I liked that one. I've done Kaplan. And who else was there? Kaplan's the one that I use when I teach. Okay. That's a great price too. Yes. So people charge outrageous. Oh, I know. So that's why I'm trying to keep it, especially as like a monthly thing, because it's $57 a month. And then plus you can ask me questions. It's not like, okay, it's all in the video and the video was 3 minutes long and you still were like, and you can rewind that video many times. You can pause. And this is another thing that I like to do with my structure. So I'll give you like an intro. After the intro, I would do like some practice problems. Like I would do the practice. So I'd say practice me. Then I will give you time to do a practice problem where you can freeze or pause the video. And then I go over it. Then after that, there is like a closure. And after the closure, I have what's called an exit ticket. The exit ticket I kind of like. Because when you do the exit ticket, you can only get the answer if you see the next video. So it really makes you to take the next video. Even if it's something that you know, you just fast forward it, right? Just fast forward straight ahead. That's it. So you have control of like, if you watch it, you're like, okay, I got this. Then you fast forward it. Do the exit ticket, move on to the next video. All right. But if it's something that you're like, ooh, let me stop and really slow down and pay attention to this, then you stop, slow down and pay attention to it. Okay. And then if you have further questions about it, just take a little picture of it with your phone, send it to me as a text, and I'll be like, all right, cool. I'm going to talk about this during my first live the very next day. Or if it's like, around 11 o'clock that same day, all right, I'm going to talk about it on the same day's live. And then you'll get your answer. A second. It sound nuts. Okay, that's exactly why I haven't found purchase online, because they don't have any communication. Yes. Amazing. Thank you. Yeah, so I figured that this would be a little bit easier. Okay. So I know a lot of people are like, oh, people are always selling me stuff, but I'm going to be truthful. Like, if you really want to get good quality, you know my work. I hope you know my work. If not, you got YouTube, you got replays, you know, you can look, find me almost anywhere. And then you can take a look at what I do. Or if you're not sure, you're not sure. But this price is only going to stick around for 1 week. Okay, March the 1st. I will even say midnight, next Saturday. Okay, this price is going to go up to $87. Okay, you only got 1 week. And this is the one thing. The reason why I do this, because I love you. I love adults. But when you give people so much time, they either, one, forget about it. Two, they're like, I don't want it. Or three, when it's already past the time, they're like, oh, can you add me to? And I'm going to be like, no. All right. So I am a stickler about time as best as I can. So March the 1st, that's when price is going to go up to $87. Okay. All right. So I will be mentioning this, probably going to go live tomorrow. I'm not sure what the topic is going to be, but I want to do a little bit more with piecewise function. But this is what it is. Like, think about it, let it marinate, tell to your friends, talk to whoever else you know that's having trouble with GED, also ACCUPLACER, also ASVAB. They need to get that algebra. I already have 3 people taking the course as is right now. So just let me know. Okay. So if anything, okay, Native Ash, I will definitely, is it on your site right now? Well, I want to put you on with the, because what's on my site is the full amount. So that's why I always like to do the subscriptions a little separate. So Native, I'm going to email you so I can get your info so we can get that situated. If there's anyone else that wants to take on, please do not hesitate. Okay, do not hesitate. You can just say, yes, sign me up now. Or you can message me. All right. Okay. All right. So let's get back to the piecewise. All right. Back to the channel. Not a problem. All right. So we are getting right back. So I really want to not freak anybody out about the next one. So I'm going to cover that one up. But I'm going to really focus in on this one. So piecewise function. So if we have, do you pay every month or it's in full at the beginning? You pay every month, right? Yep, you just pay monthly. So all I personally need is a 3-month commitment. But if you pass your exam before the 3rd month, or maybe even before the 2nd month, boom, I will dismiss the other months. I'll only have you charge for what you need. But if I definitely can get 3 months, I would greatly appreciate that. Okay? Okay. Hi, Impact. Another great teacher. Yes. She is amazing. If you guys are not following Miss E, okay, Impact Math teacher, please go ahead. Impact Math. It's usually Impact Math 19, or is it Impact Math teacher? Okay. Calculus. I failed my exam. Yeah, I haven't done calculus as of yet. Yeah, but here's my thing. If you need a calc tutor, let me know, because I got a guy who's amazing. Like, that's all he does. And he's very patient as well. Okay, so definitely message me, and then I can hook you up with him. All right, email sent. Thank you so much. Not a problem. All right, so taking a look f of x, we have negative 2x minus 4 if x is less than or equal to 2. We have 4x minus 9 if x is greater than 2. All right. So where is my boundary line? Where is that going to be? Where would my boundary line be? Thank you so much for the follow. Yes, definitely give me an email or give me a message if you do need a calculus tutor, because I definitely have friends. Ooh, so close, la, so close, so close. Not 2, but not -2, but okay. And if you're not sure, you can hit the question mark. There you go. Okay, if you're not sure, you can put the question marks. So the boundary lines is always based off the inequalities. Okay, so for those that are just coming in, my boundary line is always based off the inequality. So everything is surrounding by the positive 2. So if I see, I'm going to draw or highlight my -2, as well as, let me put a pen mark in there so you can see it. So this is going to be my boundary line. So this is when x is equal to 2. All right. All right. Oh, well, hello. All right. So I'm not sure if you heard my announcement about the course, because that will be a little bit cheaper than having me for one-to-one. If not, I'll repeat it in a moment. Okay. So now my boundary line is going to be at 2. So I want to know, for the first expression, we have f of 2. So I rewrite the expression, -2, but instead of an x, I'm going to put a 2, minus 4. What's f of 2 going to equal? Okay. So this part here is -4 minus the 4 with it. Okay, just put it all together. So I know you guys did the -2 times 2 gives you -4. Now combine that -4 with that -4. Okay, good job, pretty. Tiffany, there we go. Okay, so not just an 8, but a -8. All right, so what you just found is a point at 2, -8. So am I going to draw, now we go back to the inequality, is it going to be open or closed? Negative stay negative. Yes. Yes. Because when the signs are the same, you're basically adding them together and you're keeping the negative. So I got closed, I got open, I got open. Wait, no, I'm repeating myself. Okay, look to see the inequality sign. So there's a line underneath. Okay, there we go. Okay, all right. Okay, because you had -4, right here, -4 minus 4. It only changes when you're multiplying. We're not multiplying. We're basically adding, really. That's how we got the -8. So yes, it is going to be closed. Good, okay? Since it's equal to, it's going to be closed. So at the +2, we're going down to -8, and we're going to put a dot because it is closed. All right? So they only want us to graph when x is less than or equal to 2. So that means we should be graphing the left side. All right? So this is when we got to think the opposite. My slope is a -2. Okay, so since my slope is a -2, normally we would start at this point, go down 2 and to the right 1. But we're not graphing the right side. We got to graph the left side. So in order for us to keep that same slope, we got to think the opposite. We need to go up 2, but to the left 1. Draw our point. We have to go up 2 to the left 1. Draw our point. And we can keep going. 1, 2, left 1, 1, 2, left 1. Okay? Keep drawing until we see, oops, our line. Let me get my finger out the way. Kind of went a little overshot it a bit. Let me clean myself up over here. Okay. How are we feeling? Because this is new. This is new. And it's new on a Saturday night. Okay, this is new. And it's okay. So tap if you're all right. Put a question mark if you're not. Okay, we still got some hearts. There's still some heartbeats going on over there. Okay, we got a question mark, got a question mark. All right, so now, in order for us to keep this slope going, all right, did you understand how I got the point at 2, -8? Okay, do you understand how we get from 2, -8? Okay, I got a yes, I got a yes. Who else was missing? Native Ash, you okay? Do you see how we got that 2, -8 for a point? Okay, Desi, good. Native Ash, you still there? -4 minus 4. Yes, Chris. Okay, so we got that point. Not? Okay. So what we did was we got the 2 from the boundary line. So the 2's was my boundary line. So we took this 2 and plugged it into our expression. So that's where the -2 times 2 minus 4 came from. Then we did -2 times 2, which gives us a -4. And then when we minus the 4 with the -4, we got the -8. So what we found, not really, okay. So are you seeing how I got the -8 now? So we plug the 2 into the expression, -2 times 2 minus 4. So -2 times 2 gives me -4, and -4 minus 4 gives me -8. Okay, all right, good. So that's the point that's right here, that 2, -8. And it's closed because the inequality sign was less than or equal to. Since it says less than, we're looking at numbers or looking at the graph to the left of it. We're used to saying, okay, my slope is a -2, so I would go down 2 to the right 1. But we don't want this part of the graph. We want this part of the graph because it's a piecewise function. We only want parts of the graph. Okay, you're following. Okay. So we don't want this part of the graph. We only want the part that's to the left because my x's are less than 2. All right. So with that being said, that takes care of this top expression. Now we're going to take care of this bottom expression. So we need to find out where should we put our point on this boundary line. And the way we do it is we're going to take this 2 and plug it in for x in this expression. So we have the f of 2 is equal to 4 times 2 minus 9. Okay, so we just substitute this 2 in for this x, and we're going to try to find the y value of the point. Okay, well, hello, Lynn. Okay, so pretty one says it is a -1. What does everyone else say? Okay, I got another -1. My LA, -1, Chris Gates. Tiffany got -1, -1. All right. And anyone good. So we have 8 minus 9. That does give us a -1. So the ordered pair is going to be 2, comma, -1. Okay. Good, Michael. All right, good, Des. Here we go. All right, look at us. Look at us go. All right, so is it going to be an open or a closed? Is it going to be open or closed? Look at my inequality. Okay, Pretty says open. Michael says open. Who says open? Okay. Hello, Lisa. Welcome in. I said open. Okay, one more. Yes. All right. So at 2, -1, we have an open circle. All right. Now, we're dealing with the x's. X is greater than 2. So that means we are graphing just the right side of this boundary line. So from this point, I'm going to go straight to my slope. And my slope is a 4, which we all know it's going to be 4 over 1. So since we're graphing the right side of that boundary line, we don't have to do any switcheroos. We can just graph just as we see it. So that means from this line, this point, we're going to go up 4. 1, 2, 3, 4 over 1. Draw a point. 1, 2, 3, 4 over 1. Draw a point. And I don't think I have any more. 1, 2, 3. 4 will be over there. Somewhere around here. All right. So I'm just going by these 2 points. So from here on up, okay. So what we just did was we graphed the right side of the boundary line. So when it comes to piecewise functions, you're not really using the y-intercepts of your graphs, y-intercepts of your equations to graph, but you're using it to find your points, to find the y values of the points. But you're going to, once you figure out what that point is, if it's open or closed, then you're going to just use the slopes to help graph the lines. Because there's no equal sign. Yes. It's open if it's greater than. Yes. If it's just greater than or less than, let me put it up here. So we got greater than or less than, it's always going to be open. If it's greater than or equal to or less than or equal to, it will be closed. Okay. What does open and close mean? The dots. So it's either going to be an open circle or a closed dot that you're putting on the graph. Got it. Awesome. Okay. How are we feeling? We can do thumbs up. We can do thumbs down. Whatever emoji that you think best represents you, go ahead and flash them up. And if you get a chance, go ahead and keep tapping the screen, just so TikTok knows that, yeah, there's people here doing math on a Saturday night, and it's 10 o'clock. It's 10:03. I like the note reminders. Good, good. Oh, I love that. People feeling strong, liking, good. All right, nice. Oh, thank you for the follow, Michael. I appreciate it. Yeah, I try to make math fun as best I can, and I really like to emphasize on breaking concepts down. Okay, I really do. I usually don't come every night, but tonight I really just wanted to come on and to present that. Now, be truthful. Do you think you want to take it up a notch? Do you think you want to step it up just a hair? Or do you want another one that's relatively close to what we're doing? What do you think? No? Thank you for your honesty. She's like, oh, hell no. We got like a yes, please. Okay, close. Okay, something close. Okay, yes, please. Another one. Okay, baby steps. Okay. I love that. I might break it out tomorrow because I might even like continue doing the piecewise maybe tomorrow. All right, let me see. You know what? I will continue doing the piecewise tomorrow. But let me use this one. Okay, baby steps. Gotcha. Let me tell what I learned. Exactly. And that's why I ask. You know, some teachers don't ask. They're like, all right, this is what you're doing. You're like, whoa, player. Can I just marinate just literally for 5 seconds? Can we do that? Can we do that? And most teachers are like, no, you got it. Everything's good. Go ahead. You're like, no, it's really not. All right. So looking at, let me see if I can. Where all my papers go? Okay, I can use this one. Yeah, I don't want to shock you with number 2. You're going to be like, oh no, we're not doing that. All right, so we'll just do this. And we'll do that. Okay. All right. Do you know how much questions are used in the SATs? Oh, they vary. They really do vary. Sometimes it's 34 because remember there's two sections. All right, so there's one with the arithmetic that you do not use a calculator for, and there's one that is a calculator based. So it could be like 34, sometimes 42. Sometimes they switched it up. One year they had 52. I don't know what they were smoking, but they had 52 for one of the sections once. And I think it was the calculator section. So, or no, the non-calculator section. Yeah, so that's why they always have like these crazy released questions, because they realize that, whoa, that was too many questions, and they're always releasing stuff. But if anything, you could use, who do I use? Sometimes I use Kaplan, sometimes I use Princeton Review. But I don't like to use, I think it's called Momentix. It's not bad, but it's not really honing in on SAT. They just hit on all the stuff. So if you're going to do it, might as well do Princeton or Kaplan. All right, not a problem. Okay, so taking a look, always go from right to left. That's how we do piecewise functions. So if we start on the right, it'll tell me where my boundary line's supposed to be. Where should my boundary line be? Oh yeah, yes. That was the other one. Barron's I've used before. Yes, 2. Positive 2. Good. Okay. So your boundary line should be here at positive 2. I'll try to do it up with the line so you can see it. So that is when x is equal to 2. All right. So now for us to figure out what point should go on that boundary line, we're going to substitute the 2 inside of the expression. So if we're talking about the f of 2, and we have negative 2 times 2 minus 1, what is my f of 2? Okay. Okay, so make sure you guys give me the whole thing. So after you plug in that 2, what's my answer? Okay. All right. So negative 2 times 2 gives me a negative 4. Negative 4 minus 1, that gives me a negative 5. Okay, so when both of them are negative, just add them together and keep the sign. Okay, we all see that? All right, so that means we have a point at 2, negative 5. Okay, yes, all right, good. So since we have a point at 2, negative 5, will it be opened or closed? Yay, Tears Blonde is back. Okay, so Michael says close. Okay, I get it, Des. That's close. Why is the vertical asymptote at 2? Well, that's going to be my boundary line. So if you notice, both of them are talking about when positive 2. So this is going to be my boundary line. So it kind of helps me to know where to start for the point. Yes. How can I find if it's open or closed? So it's the inequality. If it says equal to, this says less than or equal to, that's going to be closed because you're including the 2. If it's just greater than or just less than, you're not including the 2. All right. Yes, I noticed that too. Okay, perfect. So it's going to be a closed at 2, -5. So putting our point right here. Okay, so they want us to look at the side. X is less than or equal to 2, so they only want us to do the left side. So now we need to look at the slope. The slope that they're giving us is -2. That works if I'm graphing the right side because I would have gone down 2 over 1, right? But we don't want to graph this side. We want to graph this side. So instead of going down 2 and to the right 1, we're actually going to go from this point up 2 and to the left 1. Okay, up 2 to the left 1 because it's still showing a negative slope. Up 2 to the left 1. All right. So since they want us to graph when x is less than or equal to 2, that means we need to graph the left side of our boundary line. So let's see if I can do this. Okay, perfect. All right. So that's the graph, the side that is less than or equal to 2. Okay, so how did we get 2 as the first number? Because it's what was given at the inequality. Okay, so I understand the 5. Okay, so rise and run, yes. But it's almost like if you got to go opposite, rise and run of the opposite side. Or if you want to graph the whole entire line, if you do it in pencil, just erase the side that we don't want, okay? So now we have the second expression. So we need to figure out, I'm not sure if we're going to be able to see that. I'm like picking colors that you guys are going to be going blind to see. So if I wanted to go the f of 2, but this time we're substituting the 2 for the x. Okay, let me move that over so you can see it. All right. So now we want to find, they give us our boundary, which was 2, and we're substituting that 2 into the expression. So it's a -2 plus 4. What would my answer be? Get to 10,000 likes. Oh, thank you, Chris. Just like, we're right there on the cusp. All right, so I see user with a whole lot of numbers too. La has 2. I hope you don't mind if I just call you La, because I don't know. I don't know if it's Cohill or it's LA. I'm just sitting here just calling you, making up. Made it. Yay, thank you. I don't. Okay. So answer is 2. Perfect. So that means Is it going to be an open or a closed for this point? Is it going to be open or closed? Look at the inequality. Okay. Why'd you change it to 0? Put it back. All right. So Michael says open. Native Ash says open. I said open. Says closed. Hello, Derek. Okay. George. What a J. Says open. Well, welcome in, George. All right. Can I get one more? Oh, D. Benji. I was like, I'm confused about open and closed. Okay. So I meant open. I thought it was a -4 plus 4. Okay. So, a -4? Okay. All right. Yeah, I'm glad you changed it back. So it is a -2 plus 4, which gives me 2. Now, for the open and closed, you're looking at the inequality. If it's, in this case, it's less than or equal to, anytime they have a line underneath it, it's going to be a closed dot. If they don't have a line underneath it, it'll be an open circle. Okay. All right. So at 2, positive 2, it's going to be a open circle. All right. So that's an open circle on that boundary line. So now we got to graph, and they want us to graph when x is greater than 2. So they want us to graph just to the right of this boundary line. So my slope is a -1. So I don't have to change things around for this one. All I have to do is start at my open circle. I'm going to go down 1 to the right 1. Plot a point. Okay, if you don't see a number, it's assumed that there's a 1 in front. So 1 over 1. In this case, -1 over 1. So that's why we go down 1 to the right 1. Down 1 to the right 1. Until we see our line. Then we're going to draw our graph. Okay. So this is our piecewise. Okay, this is our piecewise. So we have part of the equation that represents -2x minus 1, and we're seeing it from the left side of 2. Then we have our -x plus 4. We got this part, but we're seeing it from the right side of 2. And that's our graph. Where did the -1 come from in the first equation? From this expression. From the expression right here. So we're taking this number and plugging in for x, and then we're solving to figure out what our y value is. Good. Okay, thanks. No problem. All right. So we learned a couple of things today. All right. So we learned about that I have finally released a course or courses to help people with GED, ACCUPLACER, ASVAB. Okay. If you want to get more information about it, if you want to talk about it before signing up, if you just want to straight sign up, make sure you message me. Okay. Make sure you message me so I can make sure I get you started. I already, like I said, I have 3 people already started on it. And again, yes. Oh, good, Chris. I'm glad. It's like, what is Fran? Look at Erin. How are you? What is the ACCUPLACER? Now, the ACCUPLACER is usually used for people that are going into the community college and they want to figure out which math class they should go into based on their skill set. So they give them this test, and the test is you cannot bring in, where is mine? Somewhere underneath all these papers. You cannot bring in your own calculator. There's only certain parts of the test that there is an electronic calculator that's there, but majority of the test you cannot use a calculator for, regardless if you have special needs or any needs whatsoever. You're just going to be given extra time. So they want to know what is your math skills so they can figure out what math class you should go into. Like, should you go into basic intermediate algebra 1, which is like learning about positive and negative integers, solving one-step, two-step equations, and maybe do some graphing. Or do you start in intermediate algebra 2, which starts with a lot of the graphing piece, and then you talk about quadratics a little bit more? Or is it intermediate or college algebra 3, which gets into more of what you see, like, say, in algebra 2, and you talk about the unit circle a little bit more? Okay, so those are those classes in the community college that is non-accredited, but you're using it to build yourself up into college credits. Okay, so that's why I work really hard to help students go past that, so they're not spending a lot of money on basic math classes where you can get it for free by being a high schooler, right? Okay, sure, no problem. Can you do another, please? Oh, I don't know. Maybe I can. Wait a second. Let me see what I can do. Okay, I could probably do this one. Yeah, all right. I'm going to do just this top one. And this will be my last one. It's got to come early. Just kidding. All right, and I'm probably going to do some more Piecewise tomorrow because I'm going to come on again tomorrow night. I know, I didn't say I was going to do it, but here we are. What is this? Oh, thank you. I appreciate you. Thank you. Not a problem. All right. Okay, so should I leave you alone with this and then we'll check answers later, or should I walk you through step by step? You choose. You choose. Okay. So I got one with step by step. Step by step, step by step. Okay, walk us through. Well, hello, Tennessee Bunch or TN Bunch, sneaking in here. All right, I'll walk you through. Okay. All right, so here we go. This is called Piecewise Function. So you're not graphing. We're so used to graphing the entire line. Like, these are the two lines. One is f of x is equal to x. It's just another way of just saying y is equal to x. And the other way is y is equal to negative x plus 4, right? So we have two equations, but we don't want to graph the whole entire thing. They're giving us some restrictions. But the restriction is surrounded by what's called a boundary line. So the boundary line is what's happening here in the inequality. It's all surrounded by -1. So I can go and I'm going to draw my boundary line because it kind of helps me. Some people, after a while, you don't have to draw the boundary line. So I'm going to highlight it. And I'm going to put it in blue. Okay, just so you can see. So this is going to tell you when x is equal to -1. Okay, so this is when x is equal to -1. But I want to figure out what is my points for each of these equations. So what I'm going to do is, for the first one, I have f of -1. And I'm going to plug in the -1 in for the x. Okay? Which simply gives me a -1. Because it doesn't give me a plus or a minus a number. So I don't have to alter anything. So the ordered pair that I'm going to put on my boundary line is -1, -1. Okay, yes, it's because the x is alone. Good. Oh, hello, Lisa. All right, so when we substitute the -1 for the x, we got -1 out. -1 went in, -1 went out because x was just by itself. So now, we got to take a look at the inequality. The inequality is going to tell me what type of circle or dot that I'm going to draw on my line. So if it's equal to, less than or equal to, or greater than or equal to, I'm going to have a closed dot. Greater than or less than, it's going to be an open circle. Okay, so yes, it is going to be closed. But here you got a new point. Yes, you do got a new point. So it's not going to be 0, 1. Okay. So we're at -1, -1. And since it is a close, is equal to, it's going to be a closed dot right there. Okay. Ooh, I don't know if you can see that. So we went from -1 to -1, and since it was equal to, it's a closed dot. How are we doing? Yes, so domains are your x's. The domains are your x's, okay? All right? So now, they want us to graph not the whole entire equation, not the whole entire graph. They only want us to graph when x is less than or equal to -1. So they only want us to graph the left side of our graph. So now, here's a question for you. What's my slope for that expression? What's the slope? With the bracket, parentheses, and solving for domain. Okay, I think I know what you're talking about, Peggy. Okay, give me a moment. Let me finish this thought, and then I'll substitute. Okay? All right. So my slope is not the -1. Slope is what's in front of the x. What's in front of the x? Okay, there we go. Lisa, there we go, La. There we go, Peggy. Yes. D, Benji, yes. Nita, yes. There we go. Sugar, yes. There we are. So if my slope, if I go back to my graph, so from this point that's on the boundary line, normally I would go up 1 to the right 1, right? Up 1 to the right 1. But that means I'm graphing just the right side of this boundary line. But we are supposed to graph when x is less than or equal to -1. So that means I got to graph the left side of this boundary line. So instead of going up 1 to the right 1, I got to go down 1 to the left 1. Because a negative divided by a negative will give me my positive slope. So I go down 1 to the left 1, down 1 to the left 1. Okay. So now I'm just graphing we're going to pretend that line went through all the points like it's supposed to. But this is what's happening. So if you want to, that's why sometimes when I do piecewise function for the first time, I just let my students graph the whole entire line, and then with an eraser, they'll erase the right side because we're only looking for the left side of that graph. Does that make sense? Okay, are we okay? All of a sudden the heart stopped. Everybody's heart stopped? Okay, I got I mean, it's just like a thumbs up, tapping of the heart, something. Just want to make sure that you guys are okay. Okay. What that means. Okay. Got it. Yes. Smiling. Thanks. Okay. So that takes care of the first expression. Now we need the second expression. So with the second expression, we're going to plug in. So I'm going to do the f of -1, but we're going to plug in the -1 for the x. So that means there's a negative parenthesis, -1 plus 4. The reason why I put a parenthesis around that -1 is because we generally will do this. Oh, there's a -1. You make this negative and that negative into one long negative. No, 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 no. It's a negative times a negative. Negative times a negative, that gives me a positive. Bring down my plus 4. That means my f of -1 equals 5. Okay, so all I'm doing is taking what was my boundary, because I want to find out what is the point on my boundary line so I can start my graph. But by doing that, I can take this -1 and plug it in for x in this expression here. So when I get minus a -1, it gives me a positive 1. And 1 plus 4 gives me 5. So the point that we're going to put on the boundary line is -1, 5. Okay. So when I look at the inequality, it's x greater than -1. Okay. X greater than -1, is that going to be open or closed? That's fine. At least now you're understanding, which is good. Okay, we got to remember, it was the first time you're seeing this. All right, good. Open, 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 open. Yes. So at point -1, positive 5, I'm going to put an open circle. Now, since we need to graph, because it says x is greater than -1, so that means I'm going to be graphing just the right side of this boundary line. So if I'm going to graph just the right side of the boundary line, that means I need to look at the slope of my expression. And what is my slope? Okay, make sure you get the signs. Now remember, slope is always next to your x. The slope is always next to the x. There we go. And make sure you get the signage. There we go. Okay, so it's not the 4, it's the -1. The -1 is what's next to or adjacent to your x. Okay, so since it's a -1 coming here, starting at my open circle, that means I'm going down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Okay. You can do it as many times as you feel that you can see the line. You don't have to get ridiculous with what I'm doing over here, but but if it helps you draw a straight line, do that. All right, so starting from your open circle. Okay. You see it? Okay. Hello, Lily. All right. So we didn't have to change because we were graphing the right side of our boundary line. So we can just follow the slope the way it is. -1 over +1. -1 over +1. Down 1 to the right 1. Down 1 to the right 1. Okay, and the left side goes away. Yes, and the left side will go away. Yep, if you did the whole entire line, the left side over here will go away. Okay, so we're not doing limits. But if we were doing limits, it does not exist. Yes. Because they have to be from the same point. Like if I was going down from here, the limit would be at -1. But since there's a gap, it doesn't exist. All right. Okay. All right, so that is all I'm doing for tonight. Because I'm tired. Guys coming all late. I've been here since 8:30. It's like over 2 hours. But I'm hoping that you guys have a pretty good gist about it. Okay? But the ones that I didn't do tonight, I'm going to do tomorrow night. I think I'm going to be here at 8:30 tomorrow night. And basically the same thing. So if you are a person that is going to be taking the GED or the ACCUPLACER or ASVAB, let me know, because I am actually doing, or I have courses that will kind of help you along with that. And then whatever questions that you have, you can bring it to the live and you guys will basically take precedence. You will take, first come will be you guys. So I can answer your questions and then we'll take it from there. Yes, ready for tomorrow. I was super late. That's okay. It really was last minute because normally I would try to put something out and I was like, you know what? I think I'm just going to do it tonight and see who comes in. But I will try if anything, I will definitely be doing it tomorrow night at 8:30 because I don't have anyone at that time, so we can get stuff done. All right. Hello, Sarah. Oh, thanks for the follow. Come back tomorrow for more Piecewise Function. Yes. Oh, nope. I lied because I did tell Peggy I was going to help her with domain and range. Peggy's like, what about me? I'm sorry. Oh my goodness. Let's see. How should I do this? Okay. So if I said x is less than 5, I could also say -3 is less than or equal to x, which is less than 7. Or I can say -9 is greater than x. And another one would be, let's see. So like 1/2 or -1/2. Oh, I can do that. You probably won't like me, but I can do that. Is less than 3. I'll keep it simple. All right. So let's do this. Okay. I just said, can we do it tomorrow? Nope, we're going to do it tonight, Peggy. We're doing it tonight. I can sleep when I'm dead. Don't worry, I'm okay. God, hey, I went to church today. All right, God and I are on a nice little plane right now. Okay. You were confused about, let's work on the domains because that's what I just basically did. So if we're working on domains, if you are including, just like how we said less than or greater than, it was an open circle. But when you're doing what's called, interval notation. When you're doing interval notation, instead of an open circle, it's going to be a parenthesis. That means it's unbounded, okay? You can keep going, just like infinity, okay? Positive infinity or negative infinity, you have your parentheses. But if I say, let me slide this, actually, let me do this for a second. If I say less than or equal to or greater than or equal to, it would have been, for inequalities, a closed dot, right? A circle, just a dot. Or a filled circle. I don't know. We're getting off bougie nowadays. But for interval notation, that will be brackets because you're including them. Think about a cage. You're keeping them in a cage. Parentheses, think of a bubble. You can stretch that bubble and eventually it'll burst, but you could stretch it more so than a cage. Like a cage is very solid. You're not breaking out on it, okay? Yes. Good. Okay. All real numbers, yes. Negative infinity to positive infinity, left to right. Now, here's the key thing. You always have your lowest number first. Then you put your highest number. Okay? So the way that we did with the negative infinity. So if I think about it, x is less than 5. 5 is my highest number. But my lowest number, it doesn't give me a stop. I can be at -1, I can be -15, -25, -2,468, whatever it is. But I can keep going all the way to negative infinity. Okay. That literally clicked. Good. Okay. I love clickings. Okay. But since it's infinity, infinity is not bounded. Okay? Infinity symbols always get a parenthesis. Now, since it just says less than, it doesn't say less than or equal to, it just says less than. So that means around my 5 is also going to be a parenthesis. Okay? Because if it said x is less than or equal to 5, it would have been negative infinity and a 5. Infinity will get the parenthesis, but the 5 will get the bracket. Okay, so the inequality symbol is kind of telling you, yes. Awesome. Hey, I love this. 2 people's like, yeah, getting it now. Okay. All right. So that's that one. So let me cover just a little bit so you won't get so overwhelmed. All right. This time we have what's called a compound inequality. So we have 2 things going on here. We have from -3 all the way to +7. Okay? We don't have to worry about what's inside. These definitely confuse me. But see, think about it. They're like bookends. You know how we used to, oh no. Do you guys know what bookends are? Just entertain me. So bookends is like, 2, can I say a yes? Maybe? All right. These are the ends. All right. Yes. Oh, thank God, Petty. Okay. So these are the bookends. Put the bookends together. Now, the inequality that's closest to the -3 is going to represent the -3. The inequality that's closest to the 7 is going to represent the 7. So on -3, do I get a parenthesis or a bracket? Yes, it's a bracket because it's equal to. Good, Janae, good. All right. Yes, it is going to be a bracket because it's equal to. Anytime it's equal to, it's a bracket. The only ones that never get brackets is infinity symbols. Okay, infinity, there's no boundary. But at the -3 right here, there is a boundary. So what do you think at the 7? Parenthesis, you can just show it. Parenthesis or bracket. There you go, Peggy. Since it doesn't have the line underneath, there we go, Janae. There we go, LA. Hey, crafty girl. All right. So you put the parenthesis. Okay, so this is interval notation. Okay. Let's see if I can fold this one. Can you tell I was a teacher that didn't have much of a budget? Let's fold this paper. Simply Angel. Hello. Nice to see you again. All right. So now we have -9 is greater than x. Ooh. Let's listen to that. -9 is greater than x. So that must mean that x is less than -9. If you can't see it, rewrite it. Okay? And yes, we will be using parentheses. Now, what's my lowest number? What will be my lowest number if x is less than -9? Okay. Not 1. Negative infinity. Yes. Okay, for negative infinity. Good. I know everyone's like trying to find the infinity symbol. Yes. So we have negative 9. That means we're talking about negative 10, negative 11, negative 562, negative 1,248, negative, all the way to negative infinity. Anytime they have a one-sided, like x less than, that means your lowest is always going to be negative infinity. Yes, Catherine, good. So we went from negative infinity to what? What's the stopping point? Negative 9, negative 9, good. Okay. And just like LA said, negative infinity, parenthesis. Negative 9, also a parenthesis, because it's just less than. Okay, how are we feeling? Hello, Maria. I didn't even think to put a negative in front of infinity. That was good, Janae. Good. Good. Okay. All right. Okay. With you, I can do this. Yes. You can definitely do this. All you guys, I'm not saying you can do this. You are doing this. Okay, so here I am trying to be fancy. So we have negative 1/2 x less than 3. I want to get x by itself. Okay. Yes, no problem, Lisa. If anything, I'll be on tomorrow at 8:30, or we can do our usual Monday and we'll do all that shenanigans. Have a good night. All right. So we want to get x by itself. Anytime I see a fraction, yes, hey, cat, dog, multiply by the negative 2, flip the sign. Why am I flipping the sign though? You show us how to graph them? Yes, I will. Okay, it's a negative number because you always flip the sign with a negative. But what are you doing? Not with a negative, because if I said, I know, me playing devil's advocate here. Let me unfold my paper. Because if I said 2x is less than negative 6, and we divide both sides by 2, do I flip the inequality sign? No. Good, Lisa. Why? Only if you multiply and there we go. All right. So if you multiply or divide by a negative number, that's when the inequality sign flips. So back to my folded papers. All right. So when we multiply this time by a negative 2, the reason why we multiply, because we have originally division, you do the inverse, which is multiplication, and you multiply whatever your denominator is. So negative 2, They will cancel out, give me a 1x or just an x. But since we multiplied by a negative, the inequality symbol is going to change from less than to greater than. Okay? You're not dividing in this case. Nope, but I'm multiplying by a -2. Anytime you multiply or divide by a negative, you change the direction of the inequality. So this will give me a -6. So x is going to be greater than -6. Are we okay? You guys okay? No? Okay. But only when multiplying, dividing by a negative? Yes. That's when you change the inequality. Any other time, it stays exactly the same. It's only when you multiply or divide by a negative number. I have to keep that in mind. Yes. She's like, I don't like fractions, and that's fine. But here's the thing. When the denominator and the whole number is exactly the same, it gives you 1 every time. Okay, that's why we multiply both sides by whatever the denominator is so they can cancel out. So then you don't have to deal with the fractions. Okay. So now we have x is greater than -6. What would be my lowest number? So if x is greater than -6. Good. Good. So that means we have a -6. Is it a parenthesis or a bracket? Excellent. So it is a parenthesis. But what's going to go here, though? Good, Lisa. So remember, if it's not equal to, it's always going to be a parenthesis. But it's going to what? Not x. Because x is going to represent which number? There we go. Positive infinity. Infinity. Yes. So we're going all the way to infinity. So infinity always gets a parenthesis. Okay. How are we feeling? A lot better? Good. X is always infinity. It could be positive infinity or negative infinity, depending on the direction that you're going. Okay, Janae, better now? Good. Okay, I need more practice. Okay. Yeah, because we haven't done inequalities yet. I am planning on doing inequalities. But I don't want to leave. I know, Lisa. It's okay. We're wrapping up right now, Lisa. You can go to sleep. I swear. I swear. I'm not going to do anything else. I promise. Because my behind is tired too. It's been a rough, it's been a rough couple of days. And I have to get ready for a funeral and all that fun stuff. So that's fun. It's all right. It's all right. It's our society. Yeah, so I'm going to kind of summarize a little bit. So we did piecewise function. All right, no problem, Peggy. I appreciate it. Thank you. But we did piecewise functions. We actually worked on how to read them from right to left, okay? How to use this boundary line so we can graph them, as well as looked at the domain is interval notation. And we will adjust this interval notation and do some more piecewise tomorrow. And as promised, I will show it in a graph. Okay, yes, not a problem. Okay, well, good night, guys. It's 11 o'clock on a Saturday night. And what are you doing? Math. Love y'all. Like, love you. All right. So please think about it. If you really think that you can benefit from having access to my courses, which will kind of help with if you're trying to get GED or ACCUPLACER instead of waiting for me to get to a certain point. If you want to do it more of like, what they call it, on demand, you can do that. Just let me know and we'll talk about that. Me too. Oh, thank you. Not a problem. I'm just here to help. I just want to make sure that you guys are going to be okay. All right. You're amazing. Have a good night. Restful sleep. No stress. Try to unwind a little bit. Trust me. It's in the brain. We just have to practice it. Okay. All right. Have a great night. Thank you so much. Wow. 11.5K. My gosh. Thank you. This is amazing. All right. So I know as soon as I start talking about the course, everybody's like, nope, we're out. She wants money. Peace. Well, have a good night, and I will see you guys tomorrow night at 8:30 Eastern Standard Time. All right? We're going to have some more fun with this, and then we'll just discuss. All right? Yes, I'm about to knock out. Yes, go to sleep. All right, bye now.